Hi guys, today we're going to talk about special segments in triangles. There are going to be four special segments that you're going to want to be able to define, identify, and sketch by the end of today's lesson. Those four segments are called altitude, median, angle bisector, and perpendicular bisector. So by the end of the lesson, you want to make sure you know what those are, that you can draw a sketch of them, that you can identify them, and that you can mark them appropriately. And then we also want to be able to define, identify, sketch, and name some properties about four special triangle centers. Those are the orthocenter, the centroid, the incenter, and the circumcenter. So there's kind of 8 big deals that you're going to want to learn about in this video. We're going to start by talking about these four special segments. As you watch the video, please use the definition, or add the definitions and sketches and properties, I should say, to your vocab sheet, so you can refer back to them as needed. These four segments are going to come up through the rest of the course, so we want to make sure we know what they are. Sometimes you might want to pause the video so that you can make sure you copy all that information into your notes and get the picture drawn. Remember, you can rewind if you need, so if I say something that you missed, rewind it, listen to the part of the video again. So, starting out with the altitude. An altitude is a line or segment that begins at a vertex of a triangle and it's perpendicular to the opposite side. So remember, vertex would be something like that. So if I draw this altitude perpendicular to the opposite side, remember perpendicular means it's going to make a 90-degree angle. So when I draw an altitude, there has to be that box showing that there's a 90-degree angle. The altitude could come from any of the 3 vertices. So it wouldn't have to start here at the top. If I drew a segment here and had it make a 90-degree angle with the other side, then that green segment would also be an altitude. A triangle will have 3 altitudes because it would have one of its own at each vertex. The second type of segment we want to talk about is a median. A median also starts at a vertex, but instead of crossing at a 90-degree angle, it's going to cross the other side of the triangle at its midpoint. Remember, the midpoint is the halfway point. So a median might start here and go to here, and that will have to make those 2 sides congruent. So if AB was the median, then we would have to know that CB is congruent to AB. Otherwise, it wouldn't be a median. Okay? Just like with the altitude, I could have started at one of the other vertices, gone to the midpoint of the other side of the triangle, and still had those 2 congruent pieces. So you have 3 medians in a triangle, just like you had 3 altitudes in a triangle. The third type of segment is an angle bisector. So remember, the word bisect means cut into 2 congruent parts. So an angle bisector starts at a vertex and it bisects that angle. So it makes this part of the angle congruent to this part of the angle. It doesn't necessarily bisect the opposite side. So it has nothing to do with the opposite side, it bisects the angle. So if I call this A, B, C, and D, I would know that angle A, B, D is congruent to angle D, B, C because BD is an angle bisector. Remember, you guys learned the word bisector, that it splits something into 2 congruent parts. The third thing that we want to talk about is called a perpendicular bisector. It does not bisect an angle, it bisects a side. It does not go through the vertex. So it goes through the midpoint of the side, and it is going to create a right angle. So we've got this midpoint, and then we've got this segment that creates a right angle. So we might call that segment a perpendicular bisector. We could have drawn that perpendicular bisector on any of the three sides of a triangle. There's a property here that's important that you want to list in your vocab sheet there. The property says that any point on a perpendicular bisector is equidistant from the endpoints of that segment. Equidistant means the same distance away. So if I put a point right here, we'll call it A, on this perpendicular bisector, I know that the distance from A over here to point B is the same as the distance from A over here to point C. So any point I could have drawn would have that same property. So AB would be congruent to AC. But if I had put it at another place, if I had put it there, we'll call it D, then that means the distance from B to D is the same as the distance from C to D. So, there we go, we started working. So we learned that BD would also be congruent to CD. So when we consider these segments, we want to make sure that we understand this last property about this particular one, because it's going to bring up a property about the center of the triangle that's created by the perpendicular bisectors. Okay, so we've got these four segments. Make sure you have them all down in your notes. Make sure you have all the pictures down. So you're going to want to refer back to them at the end of the lesson. You'll have some questions you need to answer. And then let's talk about the intersection. Remember, intersection means the place where they meet of each of these type of segments. It creates a type of a center of the triangle. We're going to learn about four centers in this video. The first center that we're going to want to learn about is created by the altitudes. Think in your brain for a second, how do I know that these are altitudes? I know that these are altitudes all because they have those 90-degree angles, and they start at a vertex. So we know that these altitudes are all going to intersect in the same spot right here. I'm going to call it A. The name. That is called the orthocenter. So the first center of a triangle created by the intersection of the altitudes is called the orthocenter. The second center of a triangle is called the centroid, and it's created by the intersection of the medians. So when you take a look here, I know that QU, PT, and SR are medians. Ask yourself for a second, how do I know that? I know that because they go from a vertex to a midpoint. I see that they're midpoints because each of those parts are not congruent. So I know that V is the centroid. So the centroid here has a property that's important that you're going to want to add to your vocab as well. It says the centroid theorem states that the centroid is located 2/3 of the distance. That doesn't say distance. From the vertex to the midpoint of the opposite side. So when I think about this, if all of QU had a length of 9, then I know that from Q to U, or Q to V, would be 6, because 6 is 2/3 of 9. And I know that from V to U would have to be 3, because there's 1/3 left over, and 3 is 1/3 of 9. So if you had the length of the whole segment, you could figure out the length of the parts, because we know that they would be split in a 2/3 to 1/3 ratio. The next center is created by the angle bisectors, and it's called the end center. So this point right here, we'll call it K. It's the end center. I know that these are angle bisectors because my marks are showing that the angles, all three of them, have been bisected. So we just want to know that vocabulary word, that the angle bisectors intersect the end center. then the last one of these, we want to know about the intersection of the perpendicular bisectors, and that's called the circumcenter. So make sure you write that down on your vocab sheet. I know when I look at this picture, at this point here, we'll call it A, is the circumcenter. And I know that because these segments, this one is a perpendicular bisector. I see that right angle, and I see the congruent marks. I see that this one is also a perpendicular bisector. I've got the right angle and the congruent marks. And then I see that this last one is a perpendicular bisector because I've got the right angle and the congruent marks. So the place where the three perpendicular bisectors intersect is called the circumcenter. Now, we learned that property that any point on this perpendicular bisector would be the same distance away from the endpoints of the segment, or the side that it crosses. So that tells us that the circumcenter would be equidistant from the three vertices of the triangle. Remember, equidistant means equal distance. So what that tells me is that A, my circumcenter here, is the same distance, we'll call this x, y, z. A is the same distance from x as it is from y as it is from z. So AX is congruent to AY, which is congruent to AZ. So if I wanted a point that would be the same distance away from all the vertices of the triangle, I would want that point to be called the circumcenter. So we've kind of quickly gone through some definitions and some properties of these four types of segments and then the intersections of the segments. So now you have some questions that I'd like for you to answer. If you go to this URL, tinyurl.com I'm struggling today, /1-6 formative, this is going to count as a formative grade. And it has to be completed at the start of next class. You can use the notes that you just took. You can use the video you just watched. But you do need to answer these questions by the start of next class. Good luck, and I will see you next class.